Greetings. This is part 1 of my video series called The Beauty of Mathematics. Before I begin, let me briefly discuss some of my intentions of this video series. So for simplicity's sake, I will cut to the chase, if you will. I am, in a nutshell, wanting to make a series to explain to you the beautiful concepts regarding the mathematics and how these specific concepts operate, their purpose, and what makes it so beautiful to the average viewer. Now, we all know that most people don't like math. Many people do like math, but they don't understand it. And by not understanding it, leads to a negative acceleration of their confidence in understanding it. My goal at the end of the series is to help you gain the growth mindset about mathematics. Now, most people who would go about this would normally do it in the opposite order, but that's not how I'm going to be doing it. My goal for the first video will be to explain the operations of finding vertical and horizontal asymptotes of a rational function. I will attempt to do this in such a manner which is precise and easy to understand. Now, if you're a sophomore in high school, I recommend you turn around now. If you're older and generally don't understand it, this is for you. Now, I don't want to confuse you. This is not a tutorial to explain how to find the vertical and horizontal asymptotes of a rational function, but simply to show you how it works, why it matters, and why it's beautiful. Now, the universe's natural laws are based off mathematics. Now, whether you think mathematics is discovered or invented is not relevant here. Whichever side of the fence you're on in this debate doesn't matter, because it's both. Whoops, didn't mean to say that. I could talk for hours regarding the laws of mathematics being discovered or invented, but I digress. The point of this is that we can all agree that the way it operates and how it works in science so well is, well, beautiful. If you don't think so, well, hence this video, I guess. With the introduction out of the way, we may now proceed. Let's begin with vertical asymptotes. Vertical asymptotes are vertical lines that corresponds with the zeros of the denominator of a rational function. What is a rational function? Well, rational functions are functions for the algebraic fractions. The numerators and the denominators are both polynomials. Well, what is a polynomial? A polynomial, if you don't remember, is an algebraic expression which holds multiple terms, consists of no negative fractional or fractional exponents, and they have no variables in their denominator. To graph a rational function, you must search for the intercepts, then plot them. The graphical concept of x and y-intercepts are quite simple. X and y represent vertical and horizontal axes, x being the horizontal and y being the vertical. Now, for anyone pursuing physics, this is not always the case. For example, position versus time graphs. Now that we've reviewed, let's speak about the vertical asymptotes. Wait, what is an asymptote? You may ask, you young mathematician. Well, they're simply the line that the graph approaches, but never touches. How would one approach the task of locating a vertical function? Well, it's a lot easier than what you may think. You simply set the denominator equal to 0 and solve for x. Now, let's speak of the horizontal asymptote. Before I explain how to address the task of locating the horizontal asymptote, we must briefly run over the degrees, which you will see later ties into this. When I say degree, I'm not speaking of degrees involving the unit of measure the entire rotation. I'm speaking of angles, by the way. I'm speaking of powers, exponents, the quantity of a given number or expression that is being raised to a certain power. So, to find the horizontal asymptote, we must compare the degrees of the numerator and the denominator of that said function. If the numerator is less than the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator and the degree of the denominator are equal to each other, then the horizontal asymptote is the quotient of the leading coefficient. This is due to each degree going on to infinity and never touch one another. If the degree of the numerator is, well, greater than that of the denominator, then there is no horizontal asymptote. Once you have this, you can draw the graph out. If you wish to check this with a TI-84 or 89 calculator, you can. Now, an oblique, or sometimes called slant, asymptote is when the degree of the numerator is exactly just one of the denominator. Now, you can solve this by using long division or synthetic, if it will work. The way this works is simply beautiful, and it isn't even difficult to understand. With the proper teaching, and the neglected sophomores, as I mentioned earlier, could easily understand it. From how a line approaches the graph but never touches just sends chills down my back. I absolutely love this stuff. Now, what to expect? Well, for the next 3 videos, I'll cover the shifting technique, exponential and logarithmic functions. And for a third video, I thought I'd mix it up a bit. I intend to discuss the Fibonacci and gold sequence. For a final video of the series, I will show you how you can understand this with ease, from high school algebra to differential equations. Anyone can understand mathematics, but you will have to wait for that. I will leave you with a quote from a British mathematician, J.H. Hargy. Beauty is the first test. There is no permanent place in the world for ugly mathematics. And I really hope that this series I will be making encourage you to either pursue a STEM major, and if not, to at least give you a different perspective of mathematics and the proper appreciation it deserves. Subscribe for updates on the series. Thanks for watching, and live long and prosper.